Hi kids, today we're going to be going over the unit circle. I'm going to explain how we get the unit circle and where all of the measurements and stuff come from. So here, whenever we're looking at the unit circle, the reason why they call it the unit circle is because every single one of these lengths, all the radii, if you will, of the circle is 1. So all of these is a measurement of 1. So I know here if I'm looking at a point, if this is my x-axis, use a little bit bigger of a thing. If this is my x-axis, I'm at 1, 0. This would be my y-axis, and at this point I'm at 0, 1. Over here, I'm at -1, 0. And then the lowest here, we're at 0, -1. So we're at a unit of 1 for everything, for each of these. And something that we should already know about our unit circle is our degrees, and I'm going to be explaining this just in degrees, not radians. I'm going to have a video tomorrow about radians. So here we're looking at 0 degrees, and we know once we make an entire revolution, it turns into 360 degrees. At the very top here, we have 90 degrees. Over on the negative x-axis, we have 180, and then 270 degrees down in the negative y-axis. And then we have a few of these others. So these other angles represent angles that we find on the special right triangles. So we have 30 degrees here. So I'm going to straighten that out a little bit more. So there's my 30 degrees. And we have 45 degrees here in the middle. It splits our 90 degrees in two. There's our 45 degrees. And then we have 60 degrees here. Oops. So there's my 60 degrees. And so we're going to get the measurements of each of these points. So the point here, point there, and point here. All three of those points we're going to get from our special right triangle. So I want to take a look at that. So our special right triangles, for 30, 60, 90, opposite our 30 degrees is 1, opposite our 60 degrees is square root 3, and opposite our right angle, which is our hypotenuse, is 2. So when we're looking at the unit circle, all of these hypotenuses, they represent the radius. They should be 1. So in order to turn them into 1, I'm going to be dividing by what they are. So here I'm going to be dividing by 2 in order to turn that hypotenuse into 1. What I do to one side of the triangle, I have to do to another. So I'm going to divide by 2. I'm going to divide by 2. And so that's going to give me my new unit special triangle over here. So my hypotenuse is 1. I have square root 3 over 2 there. And 1/2 across from my 30 degrees. And I'm going to do the same thing to my 45, 45, 90. Feel free to pause this video if I'm going too quickly or to write things down. That's totally fine. I am going to try to go a little bit quicker than normal so this isn't like a half-hour long video. All right, so for the next one, again, I'm going to divide by whatever the hypotenuse is in order to make it 1. What I do to one side, I have to do to all sides of the triangle. So then over here, I now have my hypotenuse of 1. I don't want to keep the square root of 2 on the bottom, so I'll multiply by square root 2 over 2, so that I'll end up with a nice square root 2 over 2 for each side. So we're rationalizing those denominators. And so these are the angles that I'm going to be using. These are the sides I'm going to be using when it comes to our unit circle. One other thing I want to point out, I've talked about before with my students, that whenever we're looking at cosine of some angle, it's always the x value over the r, the radius. And so whenever we're making these points, these x, y points, this means I'm solving for my x value. So my x value, if I multiply by the r on both sides, my x is going to be equal to r times cosine. Because we're looking at the unit circle, my r is always going to be 1. So my x is just going to be cosine of whatever the angle is. So whatever my x value is, that is going to be the cosine for that angle. And then it's the same thing for the y value. So we said before sine of theta is equal to y over r. So whenever we're looking at this, our y value is going to be equal to sine of our angle. So anytime we see these coordinates, it's always x comma y. They also represent cosine of our angle, comma the sine of our angle. So if I'm looking at the 90 degrees, since I already have that written out, cosine of 90 degrees is 0, and sine of 90 degrees is 1. So then here, basically, anytime I'm finding my xy coordinate, which we're going to be doing for the rest of the circle, I'm finding the cosine and sine of that angle. So for the first one, I've got a 30-degree angle. So I'm going to turn this into my 30, 60, 90 triangle just by dropping down that opposite side. And so I know opposite my 30 degrees, whenever we did our special unit triangles, is going to be 1/2. So I know that's my y value since we're going up. And then going across, we have square root 3 over 2. That's what's adjacent to. So then my point here is going to be my x value, so what we went along the x-axis. Sorry, square root 3 over 2, comma, 1/2, what we went up. So I could say the cosine of 30 degrees is square root 3 over 2, and the sine of 30 degrees is 1/2. So then the next one, again, I'm going to bring this down, creating my triangle, and this is my 45, 45 triangle. So I know my 45, 45, I have square root 2 over 2 for one side, square root 2 over 2 for the other, since the sides are the same. So then I will have square root 2 over 2, comma, square root 2 over 2. So then cosine of 45 degrees is square root 2 over 2. Sine of 45 degrees is square root 2 over 2. So this is, again, telling me my sine and cosine of that particular angle. And then the last one for my first quadrant, dropping down my opposite side so that I have a nice little right triangle. We have the 60 degree, so which is the same as the 30, 60, just a little bit inverted. So I have 1/2 that is adjacent to my 60 degrees, and square root 3 over 2. Oops, keep doing that. That is opposite. So then I'll have 1/2, comma, square root 3 over 2. So again, my cosine for 60 degrees is 1/2. My sine of 60 degrees is square root 3 over 2. And we also have to worry about our tangents. So whenever we're talking about tangent, we always said it was our opposite over adjacent, or in this case, it was our y value over our x value. So we're going to be doing that for each of these. So if I'm looking at, say, tangent of 0 degrees, then I'm doing my y value 0 over my x value 1, which means tangent of 0 degrees is just 0. Looking at my tangent of 30 degrees, I'm doing, again, my y value over my x value. Oops, I keep doing that. So I'm going to do the same change flip. So I'm flipping, I end up with 1 over square root 3. And I don't like that, it's not rationalized. So then I rationalize it, multiplying by root 3 over root 3. So I just have square root 3 over 3 for my tangent of 30. Next one, my tangent of 45. I'm doing my root 2 over 2 over root 2 over 2, which simplifies to just 1. It's pretty nice. And then my tangent of 60 degrees, we're kind of flipping what we did for the 30 degrees, so it ends up just being root 3. And an interesting one is going to be my tangent of 90 degrees, because I'm doing my y value over my x, we're not allowed to divide by 0, so this is undefined. And so that's our first quadrant. The first quadrant is what's most important because all of the rest of the unit circle is just reference angles from the first quadrant. So I'm kind of just reflecting over. And remember, reference angles are from, they drop to or rise to whatever the nearest x-axis is. So for this angle here, oh, that was a really bad line. So for this angle here, if I drop down to the nearest x-axis, then I'm going to be looking at a 30-degree angle, or 30-degree reference angle, to be more specific. So if I have a 30-degree reference angle over here, that means I would have gone, 150 degrees. So I'm taking that 180, subtracting 30, because I know 30 degrees is my reference angle. And so if I look at it, I'm basically just reflecting over the y-axis from my 30 degrees. So this point here is going to mimic my 30 degrees. So square root 3 over 2 and 1/2, but with one major difference, because we're in the second quadrant, because we went left instead of right, this is going to be a negative square root 3 over 2. And we've also talked about in the second quadrant, only sine is positive, so cosine, the x value is going to be negative. Same thing with the tangent. The tangent is also going to be mimicked. So tangent of 150 degrees is going to be the same as the tangent for 30 degrees, just negative because we're in the second quadrant. So it's going to be negative square root 3 over 3. And so for the rest of this, we're just going to be drawing out all of our reference angles. So this next one, and putting in what they would be for that particular quadrant. I don't know why I'm not making very pretty lines. Here we go. Thank God for this app. Otherwise, all of my triangles would look like trash. Well, let's be honest. All right, and so here, across from the 45, this is a reference of 45. So from 135 to 180 would be our 45 degrees. So we know this is 135 degrees or a 45-degree reference. So I'm using the same coordinates for the 45 degrees, just with a negative x because we're in the second quadrant. So the rest of this is pretty easy to fill out because you're just looking at what the reference angle is. So this last angle here in the second quadrant is going to be a reference of 60 degrees. Meaning I'm at 120 degrees. And so the 120 degrees is from my standard position, so from the positive x and moving out. So moving counterclockwise. And then here, because it's a reference of 60, we're using that 60-degree angle. And again, the tangents for these are going to be the same as the tangents for their references. So 135 degrees is going to be a tangent of, we said, positive 1 for the first quadrant. So since this is the second quadrant, it'll be negative 1. Tangent is negative in the second quadrant. And then tangent of, what would we say this was, 120 degrees is equal to, looking over at tangent of 60, it'll be the same but negative, so negative square root 3. And then we're ready for the next. So again, if I go too fast for you, that's totally fine. Just pause the video. I'm not going to be hurt if someone pauses the video, or if you put me on mute for a little bit. I kind of understand that too. Sometimes I have weird jokes, and my poor students understand that more than anybody else. All right, so then I have tangent of 180 degrees is going to be what? The y value over the x, so 0 over negative 1, which will just be 0, so that's nice. And now that we're in the third quadrant, we're again going to the nearest x-axis whenever we're doing our reference angles. So this first line here, I would be going straight up to the x-axis, which is our 30-degree reference. So 30 degrees from 180 is my 210 degrees. So then in the third quadrant, everything but tangent is negative. So I'm going to use the reference from the 30 degrees. So the square root 3 over 2 and the 1/2, just they'll both be negative. And then I'm doing, the middle here is going to be a reference of 45. So then I'm going up. This will draw me a nice pretty line since my lines suck. So we have a reference of 45 degrees here. So then this is going to be our 225 degree angle. So for 225 degree, reference 45, we know 45 is a square root 2 over 2. And because we're in the third quadrant, both of these will be negative. So we're kind of just filling all this in from what we know from our reference angles. So last one here, reference of 60. Oh, my lines suck. I think I'd be better at drawing lines. I'm a math teacher. Of course, I don't have a ruler on this, but I have the automatic thing, so that kind of helps. All right, and so 60 degrees from here would be, 240 degrees. So a lot of this I don't really have memorized, like what each of these angles are, even though I've been doing this for God knows how long. I have a master's degree in mathematics. I reference everything from the first quadrant. So I have the first quadrant memorized like nobody's business, and everything else is just from the first quadrant. So I'm always sitting there having to ask myself, like, wait, if I come from 180 and my reference is 60, so 180 plus 60 will give me the 240. Okay, so that's a 240 degree. So it's constantly was going through my head. Some people can memorize things at the drop of a hat. I can't. So because this is my 60 degree, I know I'm doing 1/2 square root 3 over 2. Again, we're in the third quadrant, so everything's negative. And then I'll go through and look at my tangents. So tangent of my 210. Again, this is a 30 degree reference, so my 30 degree reference is the really gross one. So the square root 3 over 3. And only tangent is positive in the third quadrant. Since I'm doing x over y and both my x and y are negative, that's going to cancel out the negatives and make them positive. So all of these are going to be positive tangents for this quadrant. So 225, this is the nice one, it's just a 1. Reference for the 45. And then tangent of the 240 is going to be equal to the square root 3. Again, reference to 60. So tangent of 60 square root 3, because we're in the third quadrant, tangent's going to be positive. And then down below, tangent of 270. We would be doing -1 over 0, which we can't do. So this is also undefined, like it was for the 90 degrees. Undif. So my next one, I'm drawing my little angle. So next one from 270. And then I'm drawing up, and so that's very large. This is our reference for 60 degrees since we're drawing up to the nearest x. So if I'm doing, 60 degrees from 360, that means I'm looking at 300 degrees. And so since I'm doing my 60 degree, that means I have 1/2 comma square root 3 over 2. And because we're in the fourth quadrant now, my x is positive, we're going to the right, but we're going down to get to this point, so then our y value is negative. So again, it represents cosine and sine, so cosine of 300 degrees is 1/2, sine of 300 degrees is negative square root 3 over 2. So anytime they ever ask you for something exact, this is what they're talking about. They want that square root stuff. They don't want you to just plug it in and get some gross looking decimal, because it's what they're going to be, gross looking decimals. Something irrational like square root 3 over 2. All right, next one, we have a 45 degree reference angle. So this is our 315 degree angle. So 360 minus the 45. And then this point here, so 45 degrees, we have square root 2 over 2. Square root 2 over 2. Again, because we're in the fourth quadrant, our y value or sine value is going to be negative. And then our last one here is going to be our reference of 30 degrees. We're not going up very far to get to the positive x-axis. And so because this is 30 degrees from 360, we're looking at 330 degrees. And again, our 30 degree, we have square root 3 over 2 comma 1/2. Y value will be negative in the fourth quadrant. And then last thing we gotta do is just the tangents of these. So tangent of 300 degrees. Again, we're looking at the 60-degree reference. So we're doing negative square root 3 because we're in the fourth quadrant. We're doing a negative over a positive, so it's going to remain negative. Tangent of 315 degrees is going to be negative 1. Reference of 45. And our tangent of 330 degrees, this is the really gross one, so negative square root 3 over 3. So the smallest angle, or reference angle, has the grossest tangent. That's how I kind of like to remember. And then when we do our last, so tangent of 360 degrees, it's going to be the same as 0 because they end up at the same point. So it's also going to be 0. And so that is how the unit circle is made. That is where we get the unit circle from. This is how it's dissected. So I hope you enjoyed the video. Like it, subscribe, send to your friends who have no idea why the unit circle is the way it is. This is how we make it with degrees from the special right triangles. Hope you guys have a very mathy, whatever this is for you, day. Bye!